the product of the reaction sequence below. First of all, what we can notice is that we're starting with an alkene, C double bond C, and we have a series of steps that we have to take in order to predict the product. I already wrote out all of the different steps in order, if you didn't remember the reagents, in order for you to predict the product correctly. So we will go through each set of reagents to figure out what the product of each step will be. Let's go ahead and start. I'm going to move a little bit. So we have this molecule, and the first set of reagents is BH3CHF in the first step, and then H2O2OH-. This reaction is called hydroboration, and I already wrote what hydroboration does. So basically, hydroboration is a reaction where you will have to turn a double bond into a single bond, and you will have to add OH to the least substituted carbon from where the double bond was. So let's go ahead and follow my steps for hydroboration. This is where my double bond was. I turned it into a single bond, so instead of drawing a double bond, I put a single bond down. And now these are the two carbons that were holding my double bond. This carbon is attached to 3 other carbons, and this carbon is attached to 1 carbon only. Therefore, this carbon is more substituted. It is tertiary, and this carbon is less substituted. It's only attached to 1 carbon. It is primary. I wrote here that in hydroboration, you will have to add OH to the least substituted carbon from where your double bond was. So between these 2 carbons, I will go ahead and I will add my OH here. That's the product of the first step. The product of hydroboration is the least substituted OH. The OH and the least substituted carbon. Now let's go ahead and go to part B. Part B says PCC-CH2Cl2. This reagent turns primary or secondary alcohols into a double bond O. So what we will do here is we have a primary alcohol, which is OH, that is connected to the primary carbon, and we will rewrite our molecule, and instead of OH we will write double bond O, and there will be a hydrogen here. So PCC basically converts primary and secondary alcohol into a double bond O, in this case into the aldehyde. Now let's go ahead and go to the last step. The last step is what is called a Wittig reagent. Basically, in a Wittig reagent, we will have phosphorus connected to 3 benzene rings on one side, and it will be connected to carbon with an alkyl group or hydrogens on the other side. And I wrote here that for part C, so this was my part B, this is part C. I wrote here that for part C, what we will have to do is we will have to replace oxygen and aldehyde, or ketone, in this case aldehyde, with carbon and groups attached to that carbon. So we basically cut this Wittig reagent in half. This is the half that is going to go into my molecule. And instead of double bond O, instead of oxygen, I'm going to put this part. It's carbon. In this case, it's carbon with 2 hydrogens. Now, Wittig reagent could have different kind of alkyl groups. It's not always a carbon with 2 hydrogens. It could be carbon with connected to other carbons, carbon connected to a ring, and so on. But in this case, it just has 2 hydrogens, so this is what I have drawn. And this must be the product of the 3-step sequence in my reaction. Now all we have to do is figure out how to name it. So I'm going to go ahead and I will find the longest chain that contains the double bond, which will be this chain. And I'm going to number from the end that is closest to the double bond. So I will write like this: 1, 2, 3, 4, 5, and 6. So I see that I have 6 carbons, and for 6 the prefix is hex. So I can automatically eliminate B. I must have hex. Now my double bond is on the first carbon, so it must be 1 hexene. 1 represents where the double bond starts. What carbon does it start on? It starts on carbon number 1. So I can eliminate C as well. And finally, I have to see my substituent here. I have a methyl group, CH3, on carbon number 3. So my answer should be 3-methyl, 1-hexene. 3-methyl, 1-hexene. This is Maya from Transformation Tutoring. I really hope that you enjoyed this video. Please like and subscribe, and I look forward to seeing you in more of my videos. Have a great, wonderful day full of fun with chemistry and fun molecules.